Hello, everyone, and welcome to today's LF Edge webinar. Today, we're going to be discussing the latest trends in edge computing architecture. We've got three esteemed speakers joining us today. So if we could click to the next slide, we'll do some brief intros and housekeeping. Just so you all know, attendees will be muted during the session, but if you have questions or comments, please feel free to type them in the comment window. We will try to make this an immersive and interactive discussion. And we are also leaving time at the end for Q&A. So without further ado, today you're going to be hearing from Jason Shepard of Nubix and the former chair of the LF Edge board. Joe Pearson, he's with IBM and he is the chair of the LF Edge Technical Advisory Committee, and Frédéric Debian with the Eclipse Foundation. So Jason, why don't you kick things off for us?
Yeah, thanks, Jill. Yeah, definitely, as she said, I encourage comments as we go, and we'll answer them on the fly. Keep it interactive, and yeah, and also as Jill mentioned, so I've been involved in LF Edge for quite some time, and sat on the board, and very passionate about open source and what Linux Foundation does, and also have worked with. Now you pronounced it much better than I would, Frederick. Quite a bit with Eclipse, and we had built that initial collaboration between Eclipse's Edge and IoT efforts and LF Edge, and then Joe, we've worked together for a while. I don't know if you wanted to chime in with any comments real quick before we dive in.
Joe, it seems you are muted.
Thank you for noticing. Excellent. I'll jump in real quick, Joe. I've been with LF Edge since we started back in January of 2019. And Edge is a difficult topic. And I'm sure this is something we'll get into, but Edge would not be possible without the cloud and things that we have learned from the cloud itself. So that's a topic that we may dive into a bit as well.
Yeah. Definitely. Yeah. I mean, edge computing without comprehending the cloud is basically legacy on-prem apps.
Yeah.
That's one way to put it.
It's 1990 redo. So anyway, so let's dive in. So I think next slide, first thing is let's level set a bit on, kind of edge taxonomy. LF Edge put out a white paper in 2020. So the first question was which edge? Put out a white paper in 2020, and there was a lot of confusion back then, a lot of edge washing happening, and people would say near edge and far edge and thin edge and thick edge and industrial edge, AI edge, whatever. And the reality is it's a continuum, and there's necessary trade-offs technically as you go through that continuum. So the white paper gets into a lot of detail, and Sunny will put into the comments like links to this one, and we'll talk about the 2022 one as well. But the core message in the taxonomy is there's inherent technical trade-offs as you go from kind of centralized data centers that are highly secure. You've got constant connection from your controller to the infrastructure that you're managing. Very, very established paradigms that we are seeing evolution happen as things kind of move more and more out to distributed locations, but the general principles apply. Then you've got like service providers that are developing edge infrastructure, whether it's in regional sites or telco sites, the access edge, that are going to lots of different users, but bringing compute even closer because of latency needs. Still locked up in a data center, still highly secure physically, but also on a wide area network from end users. So going across a lot of users to a broader base, but latency sensitive use cases. So I'm moving it closer. The next flip down is like going local area networks. This is literally on-prem, traditional data center, things on a factory floor, devices on a factory floor, or out in an oil refinery or retail store. So local area tends to be owned by the users. Sometimes it would be a service provider and with like CPE equipment. But if I'm doing latency critical workloads, I will always do that locally. I'm not going to run my airbag from over a wide area network, deploy my airbag, but you're going to see a blend of latency sensitive and latency critical also on-prem. And then, of course, you get to very constrained devices that historically have been very, very deeply embedded, hard-coded, monolithic images. But we'll talk today about how that's even changing, given the emergence of some new technologies. So a lot of details behind it, but the key point being is that there is no kind of one-size-fits-all. There are inherent trade-offs, and it's important to think about it from that perspective versus a bunch of ambiguous labels that are confusing to people. If you go to the next slide. So the 2022 paper that we put out as a community, it gets into more detail around management and orchestration, so that the MANO acronym for Edge, and divides it into 4 kind of unique paradigms at a high level that you would see across that continuum. So data center edge cloud, as we defined it, I'm in a secure data center. I can use tools like Kubernetes and Ansible and you name it, virtual machines, traditional tool sets. I can count on that constant connection to my controller, in the physical security. But that's evolving too. It's not to say that it's completely, there aren't things happening there, of course. The next click down would be what we call the distributed edge cloud, which is I can run Linux, I can run Docker and Kubernetes and all that stuff, but I am not in a physically secure data center. I have to assume someone can touch the box, and I'm likely going to lose connection. So I have to think more about kind of offline activity out in the field. End user devices, PCs, tablets, cell phones, things like that. Those are all well-established ecosystems around iOS and Android and Windows and the like. But also, we would consider as edge devices. And then you got constrained devices. I am outside the data center. I've got extra security challenges. I'm going to lose connection. Oh, and I'm really, really, really constrained. And so that's why historically it's been kind of hard coded. But so we'll talk about in the context of, I think, these paradigms. What are architectural considerations? How would you approach it if you're kind of building out your edge strategy? What are some emerging trends and whatnot? But first wanted to kind of start with just that level setting. With that, Joe, I'll kind of hand it off to you. So let's kind of talk a little bit about architectural considerations in this context, and kind of what you're seeing out there, and with all the work that you're doing with LF Edge and kind of the broader market.
Sure. Looking at this chart for a second, when we look at constrained device edge, I want you to think about that as almost a synonym for IoT devices. The only difference is that IoT devices may also contain fixed function devices that are not programmable. So in this context, when you see constrained device edge, think about programmable IoT devices as fitting into that category. That might be a convenient way to think about it. So when we talk about edge, there's this concept of, what does it mean to be edge native? What are some of the characteristics that would quantify this? And Jason actually touched on a couple of those key points. But first of all, when you're dealing with the number of physical machines that you could use in the cloud, whether we're talking virtual machines or actual host boxes, you think about the cloud as being virtually infinitely scalable. However, when we talk about the edge, we're actually talking about an exponentially greater number of devices. So we're beginning to talk about potentially millions to billions of devices. And that requires a very different approach to thinking about it, to orchestrating, to creating workloads, and so on. The second is another consideration Jason mentioned, especially outside of the service provider edge, outside of the data centers primarily. Networks can be potentially unreliable and slower, or sometimes they may not even be present. Okay, so that's a second characteristic. A third is that a lot of times your edge nodes, and when I say an edge node, I'm referring to both a cluster and a device. So think about all those as edge nodes. Edge nodes can be resource limited. When you think about the cloud, typically most of those limits can be removed. In the edge, that's not the case. A fourth consideration is that on the edge, you're always thinking about how can I place devices that perform compute. Let's say I'm working on data. How can I place that physically as close to the source of that data as possible? That's not necessarily a consideration in the cloud, other than am I in the same region as the data source? And fifth consideration, as Jason mentioned, in the data center, you have IT staff who are physically present that can service the machine. And those are actually secure facilities where access is limited, right? Out on the edge, that's not the case. There may not be IT staff available physically to put hands on the machines, which means other people are going to have to maintain them. And the physical locations themselves are not necessarily controlled or trusted. So think about the edge as having those 6 basic characteristics, and therefore then how we develop workloads that will run on edge nodes need to follow those 6 basic characteristics. And we can jump into that later if we want, but I wanted to mention that off the bat. I guess we're ready for the next slide.
Yep. No, we can stay here.
Okay.
Frederick said in my my Texas approach.
Yeah.
Want to get your thoughts as well. And actually, there's a white paper that Sonny you can drop in, from the Open Horizon community on some of the different principles. But yeah, Frederick, what are your thoughts, kind of like just on how you would approach edge architecture and kind of what edge native means to you versus what we've seen in the cloud?
Yeah, and essentially you touch, Jason and Joe, on many of the points that the people in our Edge Native working group at the Eclipse Foundation care about. Our perspective is, of course, a bit more application or developer-centric, given the roots of Eclipse in those kind of environments versus the infrastructure kind of work that is done typically at the Linux Foundation and the CNCF and those kind of places. But we agree on all of those things. And to us, what this brings is the fact that, cloud native is closely associated to DevOps, generally speaking, and those kind of approaches with continuous integration, continuous deployment, and those kind of things. And that's fantastic. Most of the basic principles hold pretty much at the edge. But at the same time, if you do plain DevOps, so to speak, at the edge, the same way you do in the cloud, you are in for a world of trouble. You will do continuous integration probably, although maybe you must be more deliberate about how you do patch deployment or new version deployment, because you don't want to disrupt those millions of potentially devices you have at the edge at the same time. But even further than that, you don't do continuous deployment, right? You need to stage those things, because if we talk about automotive, everyone's on the interstate, 4 p.m., Los Angeles is gridlocked. That's not the right time to push a patch to everyone, right? So depending on your particular vertical and use case, you need to take those things into account and really have this edge native mindset, so to speak, where you integrate the great principles of cloud native and DevOps, but really you morph them into something a bit different. And that's what we call at the Eclipse Foundation edge ops, in the sense that you need to have the right mindset, and you need to have platforms that really are built from the ground up to support you in being more effective from an application management perspective or even infrastructure management perspective there.
Yes, I joke, like, imagine if you were an operator on a manufacturing line and you got a message like, please save your work, we're going to reboot.
And that's the thing. There are real-life consequences to everything that happens at the edge. The factory example is a fantastic one, because this is not an IT-owned type of environment, right? This is about operational technology that has real financial or even life-threatening consequences. If I stop this factory floor for even a few minutes, I'm losing millions in production value. If I stop at the wrong moment an industrial process, maybe the whole plant blows up. And in IT, it's easy enough, to just ask people to reload the page and get the new version or the fix. you don't do that at the edge, or you don't. You do it pretty much more carefully.
Sorry, I can't get you a Facebook.
Yeah, exactly. You don't put people straight out Facebook at the edge without a bit of additional training, for sure.
So Frederick, I know you, and then follow up with you, Joe. Is like you've talked about this in the past, like lots and lots of momentum with Kubernetes. So we're talking about infrastructure sort of coming down from the IT world or the cloud, and of course the developers and the operations world sort of coming up, and this meeting of the minds. Shouldn't we just use Kubernetes everywhere? It solves all of our problems, or what are your thoughts on application of Kubernetes out in the field?
And that's the thing. Kubernetes is great technology, but it's great technology to scale your stateless workloads. And people have been to make stateful Kubernetes happen with more or less success. I would argue against it, but in any case, it's a great platform. But when you consider what you're doing at the edge, those type of applications that are mission critical with real-time requirements, then of course, containers are not always the solution for that, or in most cases are not the solution for that. That's why we have real-time operating systems and other emerging technologies to address those kind of use cases. And that's a really important consideration, because I would say that even the plain Linux kernel, when you think about it, even with the preempt RT patches, is not considered real-time by hardcore real-time people. And there are still fights around that, and it's evolving and it's improving. But can you imagine if the plain kernel is not real-time enough for you, then adding, of course, containers and Kubernetes and lots of intermediate layers won't cut it. So you need an approach where, yes, some of those workloads will go into Kubernetes clusters, or maybe the control plane is a Kubernetes cluster, probably in your data center edge cloud or something like that on the slide. But really, you need a more heterogeneous approach to be able to deploy your applications at the edge, which means constrained devices with maybe AI accelerators and other things like that, and certainly more variety in terms of CPU architecture that typically you would see in a data center, right? And all of that means that packaging this into containers is really hard, because having x86 image, ARM image, but it's more than that. It's ARM plus this particular AI accelerator. So in most cases, you simplify things and deploy straight binaries, or maybe you will do some kind of WebAssembly. That's an emerging way to address those challenges in a cross-platform way. But in any case, what you won't find is this magic hammer approach where, oh yes, I just have Kubernetes, or even the smaller distributions like K3s or KubeEdge and things like that make Kubernetes fit in smaller and constrained environments. But even with that, you need more than plain containers. You will need virtual machines. Maybe you will need serverless functions. You will need WebAssembly. And of course, you are deploying those real-time OS-based applications as well as straight binaries, that you will send to microcontrollers. So given the scope and the breadth of what you need to do, of course, you need more than just Kubernetes, although Kubernetes will always be somewhere in your infrastructure, probably.
Yeah. If you've ever seen them, I'll use this analogy for a while. Like, if you've ever seen the movie My Big Fat Greek Wedding, the dad like sprays Windex on everything. Like, you've got a paper cut, here you go, clean, whatever, like just completely random stuff. So I call Kubernetes and blockchain and all that very important technologies, but they're all Windexes of technology. just squirt it on there and you're good. You're good to go. But yeah, so Joe, so you guys, with Open Horizon as an example, so I'm hearing from Frederick, like there's a lot of tools, not one size fits all, but how do we start to kind of system together and right size the tools? But Open Horizon specifically, you guys are approaching it, with that kind of mindset, because you've got a blend of Kubernetes, traditional containers. You've even crossed over into the mobile world. So maybe talk through a bit about the approach there and how, from an architectural standpoint, you're mitigating these different sort of paradigms.
Yeah, I have a tough time explaining what I do to people.
Not just your mother.
That means you're doing something interesting.
Yeah. And then try to imagine my mother trying to explain to her friends what I do for a living. No, it's not going to work. So the best analogy I can think of, and Sunny, maybe you can put up a bad analogy banner on the screen. But if you think about Kubernetes as driver assistance technologies, right? Back in the olden days, we had some cars with manual transmission, some with automatic transmission. Then you added cruise control, which made it a lot easier to automate things. And then in recent years, we've had automated cruise control that takes into account the distance of cars in front of you and so on. And then you have level 2 driver assistance technologies that combine that automated cruise control with lane centering. And that's what something like the modern Kubernetes distributions can give you today when it comes time to running applications. They can automate a lot of the mundane tasks and make it a whole lot easier to operate your applications in these various environments, right? But you don't always want a car with all those driver assistance features, or maybe you can't afford it, right? So there are situations where you don't want a vehicle with all those extra features in there, even though they could make your life easier. But even with all the driver assistance features, and this is something Tesla and other automakers say, you do need a driver behind the wheel paying attention to what's going on, a safety driver, if you will. And that's where Open Horizon can actually come in and assist with all of those distributions and running the applications. Open Horizon does 2 specific things. Number 1, it removes the need for a safety driver behind the wheel of your automated car. And 2, it allows you to operate more than one car at a time. So basically, this allows you to operate a fleet of autonomous vehicles without safety drivers, which is a brand new way to run things. And some people may not be comfortable with it, but it allows one human person to operate a tremendous amount of work out in the field.
Yeah, and it's coordinated across platforms. So I mean, we
doesn't matter what car or manufacturer. Yeah,
there's always the elusive, like the magical single pane of glass, management thing across all environments. And we touched on this in the last LF Edge white paper, and I think that there's concepts emerging more and more. Is it's not about one magical foundation that works for everything. It's about how do you stitch all these different engines together and create more of a unified experience, which I think is it's a key goal of the various communities as we work together. Is I think first off just getting to realize there's lots of different hammers and lots of different nails when it comes to Edge. It's not just one thing or the other, but also that it's more of this orchestrator of orchestrators approach. You guys have different engines, or kind of core themes, but also some differences to stitch together the different types of platforms. So I think that's a key concept as we go through, you kind of think through Edge architecture. Frederick, so from your standpoint, there's a lot of really interesting projects within Eclipse. Maybe dive in a bit more on kind of what you're seeing as key architectural considerations when you're approaching Edge. Like how do you guys view piecing these solutions together?
Yeah, absolutely. And this really reflects the work that our community does. In my case, I work with the guys in those projects. They have all of the merit. I'm just voicing what they do there, certainly. But one important thing that we see happening in our Edge native projects at Eclipse is the fact that we are moving away from monolithic platforms, so to speak, in order to have smaller projects that evolve at different speeds and are able to accommodate a variety of needs. So, for example, a typical example of that is Eclipse IO Fog, which is a quite mature Edge platform that we have at the foundation. And the development started in 2015, so that's why it still has Fog in the name. And it builds brand equity, right? So they kept it. And picking a new name is a hassle in any case. But it's been around for quite some time, and it was built initially as this really container orchestration platform with a central controller that had many, many, many features, but was shipped as one thing. And now what we see happening in the community is that they are busy right now disaggregating parts of the platform so that the data plane in it, for example, is a completely separate, smaller project. And ultimately, IOFOG, as we know it, will evolve as a kind of distribution, a validated, pre-integrated distribution of smaller components. But then if you don't like one of those smaller components, you'll be able to swap it, maybe for another open source one, or even from a commercial perspective with a commercially supported one if you need that kind of support. And that's great in the sense that, of course, smaller projects are easier to manage, smaller projects are easier to understand, and having, of course, the right level of granularity there will be hard, because if you go too small, then it's a mess. If you go monolithic, then it's not flexible. So having the right balance will be key, but certainly I'm excited about that kind of development that's happening right now in our ecosystem. The second one is really that we see things that were initially more at the infrastructure or transport level merge a bit with applications. And this is exemplified by the Eclipse Zeno project. So Zeno is a kind of DDS for the new era, in the sense, if you are a bit familiar with DDS, it's a peer-to-peer pub/sub protocol, but it doesn't route well over the public internet. So it works well when it's left alone, so to speak. But if you try to bridge deployments in various physical locations across the public internet, it's a real mess to manage. So essentially, we had people that were very experienced with DDS and said, we want to build this next generation protocol that takes the good things of DDS but simplify things overall, and that's how Zeno was born. And now the lead maintainers of that are a little startup in France called Zetascale. So what the Zetascale team is doing with Zeno is, yes, to have this peer-to-peer pub/sub protocol, but also they have the concept of routing nodes. And those routing nodes are key because you deploy them in key locations, and they are able to provide services to the infrastructure and applications, and at the same time make it possible to bridge over the public internet those physical locations without the need for VPNs or special ports or anything like that, but still in a secure way. So what's interesting about Zeno is that it's got, for example, this notion in the routing node of the local storage. So there's a plugin system where you can configure declaratively, local storages where you have those routing nodes. And this means they will listen to the traffic and record automatically whatever matches the selector they have, right? And the selectors in Zeno are like the topics in MQTT, or, they are arbitrary names with slashes that denote a hierarchy. And what's great about this is that it's a bit fire and forget, in the sense you deploy those, you configure those, and they record whatever information they are configured for. And then you can run queries against the infrastructure to retrieve historical data, and all of the nodes will work together to aggregate the result set that ultimately the person or device that queried the infrastructure requested. And as you see, that's not a simple just transport protocol there. We are merging queries and distributed storage into something that was more of a transport thing in the past. And that's another exciting innovation because, of course, it opens possibilities. And this has been built from the ground up for the edge. This is not about trying to shoehorn a data center class technology, a bit like Kubernetes is in its way at the edge, but really those people behind Zeno were really knowledgeable about the edge, and they work in automotive and robotics and things like that. So they are aware of the challenges there. And they built something really exciting in Zeno that really integrates those edge native notions in the base protocol.
It's cool stuff. Like, and it's coming kind of more from the device up and taking into account the unique context of edge and the physicality or locality of it, and inherently, I always say that cloud scales in density and edge scales in physical distribution, and So that's interesting. And one thing that I think that people are starting to get, I mean, when's the last time your ERP system managed your PCs? Like IT 101 is you separate out the infrastructure plane and the application plane. But, in IoT, we've had everything kind of munged together, for many years. And we're starting to see more of that separation. And we see kind of device up, like kind of foundational infrastructure management, and then there's a layer of like application management, or bleeding into that as ML ops and the like. But often the application management doesn't comprehend the substrate below. And so, Joe, I guess a question for you is how do you, given there's like device up approaches and there's kind of cloud down or application down, and there are these different planes, how do you see, what do you consider some best practices of how these things come together, and how do you bring them together but also keep them appropriately separate?
Yeah, that's a tough question with a lot of different. So let me attack one aspect of it first. Start there, and then we can peel the layers. One of the concepts that Frederick kind of touched on was this idea that edge placements themselves can be fixed. They can be static, or they can potentially be mobile. So based on that, it is important that you don't make certain assumptions, and that you build everything, your architecture, the software that gets delivered on it, so your data plane, your management plane, and everything appropriately based on correct assumptions, not faulty assumptions. So for example, does your edge device know about and expose properties related to its physical placement? Right? So is that data being provided to all of the different layers of the infrastructure that need to know about it? Second, will capabilities be added or removed in the field? And will that information be exposed so that admins, whether we're talking AI ops, DevOps, DevSecNetOps, whatever, so that they can then respond appropriately? Whether that's something as simple as adding a GPU to a device, or expanding a hard drive, adding more memory, shifting a camera that may be situated over a door and moving it over 10 feet. That can have dramatic changes. That might, for example, force you to have to retrain models that a camera is currently using, right? So all of those considerations need to be exposed to every single layer of the stack, so to speak. And based on that, I think it's critical that we have a set of open standards and open APIs so that these different projects, however modular and componentized they are, know how to speak to each other freely, and you don't have all these proprietary APIs and interfaces and so on. And that's one of the things LF Edge is trying to do, to establish that sort of an open framework for the edge, and we'd love to work together with Eclipse on that as well, so that components are replaceable, they are swappable. And so that companies can, for example, go back and forth between open source components and commercially supported solutions, right? So that gets into some of these considerations. Another consideration, Jason, which I run into every day is, are people approaching an architecture from an industrial point of view or more of a telco point of view? Mm-hmm. Because they have different terminology, different considerations, different specifications, different assumptions, and so on. And if it is a telco, for example, they may look at everything as a set of network-defined functions and have certain assumptions about how everything operates within the context of the NFVs. Whereas someone from an industrial point of view may just assume that that network exists and someone else is taking care of that, and they assume everything else is on a layer on top of that, right? How do you handle other considerations, like what does development look like out on the edge? There is no development environment out there because there are so many different types of devices. Everything is heterogeneous, not like the cloud where it's homogeneous. What does a development environment look like, and how do you simulate all those different devices, right? Other considerations, security, automation, monitoring, observability? What sort of telemetry do you want to receive and act on? Because if you have millions of devices out in the field, that's too much information. And based on the limited storage on some of these constrained devices, you quickly run out of storage, and you don't want your systems to go down because the drive space filled up. Zero trust, zero touch are all important. Being able to configure devices with no code or low code capabilities, very critical. Are you going to be using open source or commercial? And what are your support options for that? What does it look like considering day zero operations versus day one versus day N operations? Because those are very, very different modes. Is this going to be a greenfield or a brownfield deployment? Because you'll approach the architecture very, very differently if you have to take that legacy into consideration. Also, as you mentioned earlier, you could be using a real-time operating system like Zephyr OS, or you could be using more of a preemptive OS, your standard Linux distributions. And how you approach workloads and deploying them and monitoring them and running them is very, very different. We're seeing this, IBM recently joined Eclipse SDV, and virtually everything that's done there is using a real-time operating system in the car, with the exception of non-critical systems like the entertainment head unit, right? So even development within vehicles themselves is very, very different depending on what part of the system you're working on in a car. And lastly, we had talked about the connectivity expectations and future proofing. So those are all considerations that need to go into place when you're saying, what is my edge architecture going to look like?
Yeah, pretty simple, really. I mean, I think the summary of kind of what you guys are both saying is, prioritize modularity, separate out. The best thing you can do is invest in infrastructure that's flexible, that's not hard coupled to your applications. That there is no one size fits all. The infrastructure provides that foundational security and flexibility, and parameters from the device, the context, the location awareness, whatever, and then the application plane on top is properly decoupled from that so that you can adapt it as you go.
Yeah, well said.
Certainly. And from a developer perspective, prepare yourself to install lots and lots of different tools, because you will have to cover a huge spectrum of things.
Yeah. But just beware of hard coupling things in general. We'll shift gears real quick. So maybe talk about some of the projects within LF Edge and Eclipse Foundation, and we'll touch a little bit on CNCF because there's some really cool stuff happening there. If you bring back the slides, Sunny, and we'll go to this one first. Joe, do you want to give kind of like a high level overview of the various projects?
Yeah, sure. When you take a look at this chart, let's start in the top right. What you'll see here is stage 3, stage 2, stage 1. That talks to the maturity of the project, how long it's been around, how well it's being adopted, and what the diversity of the contributors is specifically to those projects. So stage 1 are usually the newest projects that are just getting started, and they are trying to build an audience, if you will, trying to build a community. Stage 2, they have shown that they have value, and now we're looking to see, can they have several commercial adopters of their projects. And stage 3, they have arrived. They have demonstrated their maturity. They're going to be around for a long time to come. So when you look at that list, for stage 3, there's 3 projects there. Crano, which has been around at least 6 years or more, which was originally founded by AT&T. And what that is that's a unique project that houses a lot of end-to-end blueprints that talk about solutions. So this is code that shows if you glue together these 3 projects in this particular way, you can solve this type of problem. And it gives you the actual recipes for doing that. EdgeX Foundry, which was originally started by Dell, and Jason, you were involved in that from the beginning.
It's funny, back then, I had several camps that were trying to convince us to call it Fog Foundry. And I'm glad,
Wow.
I'm glad
Good thing you
Glad you
didn't.
I'm like,
didn't
I
know
think
that.
this Edge term's going to stick. I mean, this is like 2016 or whatever. I'm like, I think Edge is going to win out. But so yeah, glad we resisted. But anyway, sorry.
Smart. Excellent. So EdgeX Foundry is a project I like, and my project Open Horizon actually was mentored by EdgeX Foundry from the start. They have a very large and vibrant and active community, and what they do is they take proprietary devices like industrial devices that are usually fixed function, and they speak proprietary protocols. And EdgeX Foundry can communicate with hundreds of different protocols, and it allows them to easily be wired up to the EdgeX Foundry platform. So EdgeX Foundry can begin to get this stream of data from these different devices and to control them. And then once you have that data, it allows you to manipulate it and use it in different ways. And to do that, it has an embedded rules engine. And right now, it actually embeds another LF Edge project, eKuiper. And then towards the end of it, it has the ability to connect what we call northbound or up to the cloud or to a data center so that you can pass some of this refined or data limited or filtered data on to other systems that may need to ingest it. So EdgeX Foundry is kind of like a Swiss Army knife of the edge, if you will. And Fledge is the newest, most mature project that does something relatively similar to EdgeX Foundry, but in a very different way. They are a more smaller footprint solution that uses plugins to extend, and they target primarily the industrial sector as well as energy use cases. And they work with taking data directly from devices like that. So if you think about a wind turbine, for example, this can control and use data from a wind turbine, manipulate that, format it, feed it into a data historian, and pass it on to machine learning, let's say, and do other very interesting things with it. But Fledge is very, very active in that particular space. And they're the newest mature member. Under stage 2, real quick, Eve is a very interesting project, and they're the closest we have to an orchestrator of orchestrators. They're very good at allowing you with a single pane of glass to deploy workloads to container engines, to clusters, to micro virtual machines, and all running directly on top of either an OS or on a virtualization layer directly. So Eve is very good at that, and they also have the ability to provide a catalog of services to make it very, very easy to deploy these different services to the different environments. So think about them as having the capability to offer a cloud-based SaaS offering for managing these workloads anywhere on the edge. Home Edge was originally started by Samsung, and we're looking to expand that, but they're based on the concept of saying, if I have various smart devices in the home, they may speak different languages, they may each have different capabilities. How can we share the data between those different devices to make each individual device more powerful? So for example, your refrigerator may have a display on it, and your washing machine may give off information. So why shouldn't the two be able to talk to each other? Why can't I use the screen on my refrigerator to see, is the washing machine done, or what's the current state, right? So Home Edge is designed to help fulfill that promise. Open Horizon, which I mentioned before, is all about, in an automated way, allowing a single human to manage the placement of workloads across tens of thousands of different edge nodes, whether they're clusters or devices, and automatically managing those by empowering the edge nodes themselves, regardless of their connectivity, to control what gets run and to keep it running, even if you lose the internet connection or the machine gets rebooted, temporarily loses power, whatever the state, it should continue to run. Real quick funny story, I heard about a car rental company where they were designed to be completely automated as far as the checkout and operation of the vehicle. and someone rented the car and took it and was driving through the redwood forest, and they lost a cell phone connection, and the car just stopped. It wouldn't start up again, and they couldn't do anything about it because the car lost the cell connection. Open Horizon is designed to work in situations like that. So all your edge devices should be able to function in any situation. State of the Edge is a very, very different project. They are all about creating a landscape so we can understand the taxonomy, the terminology, the different projects where they fit. They help manage data like what's in this chart here. And they produce an annual State of the Edge report. And lastly, stage 1, we have Beetle, which is designed to be a complete end-to-end solution for workloads from cloud all the way to the edge. eKuiper, which is a rules engine dealing with data. Project Alvarium, which is designed to give you a confidence score that lets you know about information, how it has been transformed, who transformed it, did it come from trustworthy systems, that sort of thing. So quite fascinating what Alvarium does. And FIDO Device Onboard, or FDO. And I wanted to also mention Alvarium and Open Horizon are investigating being embedded within Eve, and FDO is currently embedded within Open Horizon. So there's a high degree of modularity and reuse going on between LF-Edge projects.
Cool, very cool. Let's talk. We've got a question, and I wanted to kind of run through some of the other projects. Maybe we'll go to the couple other projects, and then we'll talk about them in context with this question. If you go to the next slide. So real quick, so on CNCF, there's a Edge working group within CNCF. Of course, Kubernetes applies, as we talked about. There's lighter weight distributions like K3s. Alcree is interesting because they're leveraging Kubernetes resources as a way to kind of define inputs and outputs for leaf nodes, so like in an IoT sense. So there's that tool. And you've got KubeEdge and SuperEdge, which are kind of more like how do we simplify implementations of Kubernetes for the edge. And then WASM-Edge, we'll talk about WebAssembly here in a bit, but WebAssembly, and Frederick had mentioned this as well, is rising pretty quickly as a new approach or a complementary approach to cloud native and containerization or virtualization of functions, almost function as a service. So WASM-Edge is addressing that. And we're also seeing WebAssembly nested within various Kubernetes projects. So real quick, Frederick, if you want to go to the next slide, introduce a few of the Eclipse projects, and then let's talk about how you might sort of piece things together for a solution, given the question on retail specifically. But Frederick, walk us through like some of the high-level Eclipse projects.
Yeah, of course. And they are, this is just a sampling in the sense that, there are overall 415 open source projects at the Eclipse Foundation. In our IoT and Edge domain, we have 50 plus of them. So, of course, we cannot feature every. And the matrix that you see on the slide is extracted from a white paper that we wrote. And the grayed out logos are from other communities. And Joe covered many of those. Most of them are from LF-Edge. And we tried to position them to see where our own projects were fitting, on the edge to cloud continuum and the development to operations continuum. But, that kind of placement is a bit unfair, because if we wanted to really represent, there would be bands of usage or even areas of usage rather than a pinpoint. But we try to put them in the most typical type of deployment, just to make things a bit easier. So a few of the things that we have, there are, of course, IOFog and Zeno that I already covered. So IOFog is container orchestration at the edge. It integrates with Kubernetes, but can work in standalone mode as well, and really relies on a central controller. But since it integrates this network proxy, you can have nodes in various locations, and without VPNs or complicated firewall setups, have everything report back in interoperate. So that's great. Zeno, as I mentioned, is a next generation PubSub protocol with built-in support for distributed storage. We have Eclipse Kura, which is a Java OSGI fantastic project, very mature, that enables you to build gateways very, very quickly. Already supports tons of protocols like Modbus, CanNet, and things like that. And of course, from an IT perspective, things like MQTT and CoAP and all of that. So really very, very nifty project. We have a few names here that are very well known, like Eclipse Mosquito, a lightweight MQTT broker that you will find in any Linux distribution, and things that are a bit more exotic but really interesting, like Eclipse Hono, which is a kind of connectivity platform for devices. And we had a fantastic presentation at our own virtual event last week where people from a German company were describing how Hono could be used to replace Google IoT Core, which has been discontinued. So they are doing good business in migrating those locked-in people on the Google platform to a more open source solution right now. And then you will see things like JCube, Jakarta, EE, MicroProfile. So of course, those are development frameworks, but they are pretty passionate about making those things work in the cloud native and edge native types of environment. And when you consider all of those color logos on the slide, so the ones that are from Eclipse, you will see that we are less specialized, let's say, in the infrastructure segment. We integrate with what makes sense there, and plenty of good stuff that's happening at LFEdge and more broadly at the Linux Foundation. And at the same time, you see emerging at Eclipse this kind of developer focus and certainly application management focus as well, since those have been our strengths traditionally. And I can't move to the next one without highlighting also the Eclipse Ditto project, which is a fantastic framework for digital twins. Lots of traction in various verticals with that one. And once again, a very mature, well-supported project by a wide community.
Yeah, I mean, it's almost like, I mean, Eclipse is, I mean, there are certainly infrastructure projects and things like Current and whatnot, but a lot of really cool, like glue tools, as I would call it.
Yes.
Stitch it together, and Linux Foundation, more so on the provide those kind of foundational elements from an infrastructure standpoint. So super complementary. Real quick plug. I want to make sure we're good on time. We want to get to that question, but I think a couple slides from now would be good context. But a quick plug for the survey. Sonny, if you can drop this in. So you guys do this survey. I don't know, is this third year?
We've been running surveys like that since 2015, every year. But last 2-3 years, we have this concept of a dev survey and a commercial adoption survey that we run at the same time and publish different reports. In any case, all of that is when we publish the reports, published under Creative Commons. So you can remix, reuse the slides in any way and data any way you want. So please participate, because you are helping the broader open source community in understanding the current trends in the market, whether from an IoT or edge perspective. So please participate.
Okay. Yeah, very cool. So I'll put the link there in chat. So if you go to the next slide, so I wanted to kind of tie it together. So, we talked about the continuum, exponential growth in the number of devices as you go left, but they also get more constrained. And you've got all these different technologies, across the board. There is no one size fits all. But the key is, how do you build as much modularity in as you can to be able to interchange tools? One of the key points on this slide is that, historically, as we've seen cloud native come down, there's what I call the Linux barrier, where the tools, Docker, Kubernetes, anything around OCI compliant containers, virtual machines. Historically, there's a pretty hard stop at around 256 megs of memory where you can run Linux and support these types of technologies on a given edge node. We had mentioned WebAssembly a couple of times. What's interesting with WebAssembly, it was designed initially as a JavaScript, alternative, for websites, but past couple of years, it's been growing a lot of traction within cloud native, because it's effectively, it's virtualization technology. It can provide, code independence. It's very, very lightweight, and also got a really good security posture. And so we're actually seeing WebAssembly not only being used kind of to break the container paradigm even further down into functions, upstream, but we're seeing it cross the Linux barrier. You know, we've been doing work at Nubix with WebAssembly and the Zephyr community. How do we blend that over to the RTOS world? You've got Xeno that you know is kind of spreading the gamut. But I think a key message here is that we're seeing, you know, with the emergence of technologies. I mean, this was the promise of Java a while back, is that it's, you know, kind of the universal thing. But you know, great environment. But WebAssembly is kind of like a new level of that, and so we're seeing, you know, technologies even take these principles further. But when it gets to the question, so Sonny, if you want to post the question, there was a question around like, okay, so let's make it practical. How would I go about pulling something together for, you know, say a retail store? Now, obviously, there's a lot of different, you know, contexts here, but maybe Joe, I'll start with you. You know, because I know you've done work with the Open Retail Initiative. Like, you know,
Sure.
how would you approach this? I mean, it's a lot of projects. It can be almost daunting. Like, where do you get started? But what are some practical first steps?
Absolutely. So a lot of times when we try to solve a solution, there's so many different pieces out there. You're like, someone, please just show me how this works, how these fit together, and one way to use that. So there were several companies that got together. Currently, that it's Intel and Scale Computing and IBM and a few others have all gotten together to form the Open Retail Reference Architecture Group under the EdgeX Foundry project. And I believe Sunny has a link she can post directly to the wiki page for that group. And on there, they've actually had the first version of their reference architecture. And what that does is that shows the different key roles and components and functionality of different pieces that can comprise a retail solution. And then what you can do is map use cases on top of that. So a use case, for example, might be spill detection. How would you piece together a spill detection using these particular open source projects? And are there ways in which you could say, okay, I like what I see here with all these open source projects fit together, but I want to replace this one over here with a commercial solution, let's say. So what Open Retail Reference Architecture is trying to do is actually demonstrate that. So in IBM's Dallas lab, Aura has both a pure open source version of this reference architecture in place with the visual analytics model running on it. And then we've taken a second version and swapped out some of the components with commercial components. So that's one example of a way to tackle that problem.
Yeah, and you know, some other points. I know we got to wrap up here in a sec, but you know, it's Kubernetes. There's a lot of activity, I think, you know, with Kubernetes out there. I mean, Chick-fil-A. There's you know, it's a great example of a company that's adopted Kubernetes for retail stores. You know, K3S being a lighter version of that. If you need to run also legacy apps, you know, EvoS comprehends both VMs and containers, you know, in Kubernetes. So that makes sense in that regard. You can also leverage KubeVirt plugged into into the Kubernetes environment. Open Horizon, you know, makes great sense, and you also have that bridge over to mobile devices. So you know, each tool set provides you know, different benefits, and I wouldn't say they're all mutually exclusive. There's ways to kind of, you know, bind it together, and you know, that's also part of the point of the communities too, is you bringing your unique context into the community, get engaged, and you know, kind of you learn and evolve from there. You know, certainly tools from, you know, commercial providers like, you know, Palo Alto can you plug in as for the question, but it starts with defining the context and kind of piecing together the needs, and then using the right tool for the job. Let's go to the next slide, and then Frederick, as we kind of get to the summary, and any other thoughts on kind of how to approach like pick a vertical solution like retail or whatever? How do we make it practical?
Yeah, the retail one is really interesting. Personally, if we care, let's say, about video analytics in store, for example, for traffic patterns or things like that, one possible way to do this is AI directly on cameras, for example, in containers orchestrated through Eclipse IO Fog as a potential solution. And of course, for anything that would report back to an application on the server side running maybe in containers or VMs, you could use Xeno as the binding protocol, for example, for those things, and then store locally part of the footage, for example, when there are incidents or interesting things that you want to analyze further for further model training or whatever. So, the possibilities are really infinite there. But really, it's all about understanding your use case. And really, if you have real-time mission-critical requirements on one side versus more relaxed requirements for business line types of applications, and then piecing out slowly what the global architecture will be. But I think it's really important to take an incremental approach there, where you decide what's the core functionality and build outwards from there. And as you add features, explore what's in there. There are so many interesting projects at LF-Edge, Eclipse, and in other places as well. And being aware of those things is really important, because you could miss out on possibilities and flexibility if you don't explore what's there. And since it's all open source, there's no subscription, there's no tie-in. So you should feel free and empowered to make those trials and explore, because essentially looking yourself too soon in one specific pattern or one specific architecture will bite you down the road in a few years for sure.
Yeah, and especially if you go down the rabbit hole of doing it all, kind of proprietary and internally and reinventing things. There's all these great tools that are out there. I mean, take an incremental approach, as you said. Leverage the power of the community and the knowledge, the brain trust that you've that the community provides, so that you can kind of place your bets and on technologies and evolve from there, but also put most of your resources into innovation, versus reinvention. So I mean, it's a key element of open source. So I know we're at time. I mean, we've talked about a lot of different things. I mean, there's no one size fits all. Plan on kind of the orchestrator of orchestrators approach. There's necessarily different engines and tools across the continuum. But what we're trying to do as a community, and whether you're however you approach Edge, is plan on stitching together different tools. If anyone tells you that their tool does everything, run away.
Indeed.
Not the case. Separate infrastructure and applications. Kubernetes super important technology, but it's not the panacea for all things Edge. So be careful of that as well. You need flexibility. And interestingly, WebAssembly, definitely something to check out. There's a lot of really good work happening within the WebAssembly community directly within CNCF. We're starting to see just different ties happening as even finer slice of the cloud native principles that can be used everywhere, even down to microcontrollers, to create this mixes everything. Actually, we should have put that summary. Well, actually, it does. It kind of lines up with the takeaways. Windex. Just put the Windex on it. Obviously, the other thing too with AI and ML is this notion of AI coming down, Edge AI in general, is a hot topic, but don't presuppose where it runs. We're going to see increasingly these very, very tiny functions rise at tiny ML being deployed in very, very constrained devices. And those constrained devices make up the largest footprint of the Edge out there. About 2/3 of the volume of Edge devices are, that can't run Linux. And that's where I think the WebAssembly conversation is interesting, because you're able to start kind of virtualizing workloads on these very constrained devices. But so something to kind of look at, as we all talked about, Edge native, take cloud native principles, but flip it on its ear a little bit in terms of think about offline first, think about locality, various different elements there. And then we didn't get into security as much as I would have liked, but I'll end as zero trust a must. Any final comments before we wrap up?
I think overall, the space of edge computing is maturing very, very quickly compared to where it was even in 2019, where when LF-Edge really took off, and when we created our Edge Native working group at Eclipse as well. And the one thing that's remarkable there is really that, especially when you consider industrial automation or even IoT from a broader perspective, I cannot imagine a single serious deployment going forward without a dose of edge computing, right? In the past, you could imagine, oh yes, those devices will send straight to the cloud and things like that. Not anymore, because there are so many advantages to edge. And to me, edge, when we were discussing this naming discussion about EdgeX Foundry or FudgeX Foundry or whatever, right? So really, Edge was the right term to pick, and Edge is with us for a long time. So if you're new to the space, no worries. I mean, this is the right time to get in, and as the technology will continue to mature, it will be with us for a long time. So this is a tremendously useful pattern in architecture, and now is the right time to start.
Yeah, I personally don't think the pendulum's going to swing back. We've seen kind of client server, like centralized, decentralized. I think it's here to stay, given the saturation of data and all that. Any final thoughts, Joe?
Yeah, so you kind of touched on this earlier, but I think it's important for everyone to realize the edge keeps shifting its center of gravity further and further towards these constrained devices. And that's where the future is. It's managing and running workloads that do powerful things on very, very tiny, cheap devices. And I think it's going to take a lot of interesting innovation on the part of people to crack that nut on the best way to do that while adhering to cloud native and edge native best principles. And I think Jason is right that WebAssembly right now looks like the best way to create universal workloads that can run across the whole gamut from the constrained devices to the cloud.
Yeah. I mean, you look at MCUs, like a solid MCU is more powerful than the first iPhone.
Or the space shuttle. Yeah.
It's so, well, very cool. So we thank everyone for joining. Thanks, Jill, for hosting, and definitely, there's a bunch of links in the comments, to check out, and feel free to reach out to, any of us, or just dive into the communities. It's easy to get involved in projects of interest and kind of explore and go from there. And go ahead, Jill.
Yeah, and if anyone is interested in learning more about what we do, go to www.lfedge.org. We've got tons of resources there, along with some information on how to join and get involved in our communities. And just one other quick note, I just want to say that a recording of this session is going to be available on our YouTube channel within the next couple of days. So if you weren't able to see the whole thing, you can go back and rewatch it. So thanks, everyone, for your time today. We appreciate it.
All right. Yeah,
Thank you so much.
Thanks a lot.
All right, bye-bye.
All right.